włączony. Teraz słychać, tak? Teraz słychać. Dobrze. Nie, taka... Dałam, to widziałam, że jest w tym obrazie też jakaś zwłoka, bo sobie podnosiłam rękę, a to jest nawet kilka sekund nawet. 2, 3. Na życzenie Tomasza Haniszewskiego mówię test, test, test. Tak? Może to jest kwestia, że muszę mieć blisko chyba tego, nie?
Raz.
Na razie.
Good morning.
Good morning, colleagues.
I will be the first presenter. Should I do something or?
Welcome everyone. My name is Grzegorz, and together with Professor Zanaris Reinbekov from Eurasian National University Faculty of Economics in Astana in Kazakhstan, we will chair this session. Professor Zanaris Reinbekov, do you hear me?
Good morning, Professor.
Good morning.
Good morning.
Welcome, Professor. It is glad to hear you. This session is dedicated to problems of urban transport and logistics. We have 12 interesting presentations. Each speaker should present their presentation during 10, maximum 12 minutes. Then we have 2-3 minutes for questions to the presenter. If any of you would like to ask the presenter a question, please use the button raise hand in the Zoom application after presentation. Taking this opportunity, I would like to wish you fruitful deliberation and interesting scientific discussion. Now it is time for the first presentation. The first presentation has a title, A General Framework for Evaluating Driver Schedules in Public Transport. The presenter should use the button raise hand. Do we have the presenter? Yes. So please, time is yours.
Thank you very much. My name is Attila Tóth, and do you hear me?
Yes, we hear you.
Oh, thank you. So, okay, and I present the general evaluation method for driver scheduling solutions and which help to check the efficiency of the solutions and compare the optimization methods. Please, the next slide. Oh, thank you. So just a few sentences about the driver scheduling problem. There are a lot of sub-problems in the public transportation, as you know, and we concentrate only on the tasks of the transportation companies. For them, a fixed timetable with trips is given, which must be performed with vehicles and drivers. The timetable is defined for 1 day in different day types, like work day and holiday and so on, and contains daily trips. The task is to define for each trip which vehicle performs the trip and which driver drives the vehicle. And the first one is the vehicle scheduling, and the second one is the driver scheduling. And then finally the rostering phase defines the work for the drivers for each day of a longer planning period, which usually comes from the contract, like 1 month or 2 months. And these problems are MP hard, each of them. And usually they mostly solve one after the other. And of course, there are integrated methods too. Usually the vehicle and driver scheduling are solved together. And of course, it leads a better result, but it's a really hard problem. And usually they can solve only for smaller problem instances. But now we concentrated only to the driver scheduling. Okay, so here daily tasks are given, which need a driver to perform. This set can only be the timetable trips, as I said, but can contain other vehicle activities if the vehicle scheduling is already solved before. This can be like deadhead trips where there's no passenger on the vehicle, or fueling or something like that. And of course, the task is to group these tasks into duties or shifts, as you wish. And of course, each task must be included exactly in one duty. And there are a lot of rules which are given by the EU, the country, the company, unions, and so on. Like maximum working time, minimum resting time, frequency of breaks, and so on and so on. And obviously the target is to minimize the cost. Next slide, please. Okay, but how we evaluate the solution? In real industrial area, it is hard to apply published methods because the environment can be totally different city topology, different trip lengths, and different rule set and cost calculation and so on. And is really hard to evaluate the solutions. So to tell if a duty is good or not. And therefore it is hard to measure the quality of the solutions because there's no general evaluation method. Next slide, please. Okay, but what is cost? For the companies, the cost is mostly the money they pay for the employees. This comes from the salaries and the overtime cost. Usually the overtime is more expensive, much more expensive than the basic salary. But the salaries and the amount of overtime can be calculated only after the rostering, because the driver can work more in one day and less in another day, and in average they must work some hours, and the amount of the overtime can be calculated for the planning period only after the rostering. So in the driver scheduling we can only estimate the final operational cost. And since the salary and the overtime are also depend on the working time, we can say here that the less working time here results less cost at the end. But what is working time? A duty contains different activities. Some of them are obligatory, like the drivings, like the trips, the timetable trips. But others are potential, which depend on the structure of the duty, like driver changing on a vehicle or others. And of course, there are idle activities, short or longer. And some of these activities are paid and others are not. So to improve the solution, the aim is to the paid activities must be reduced. Next slide, please. Okay, how we can reduce the working time? Many activities must be performed in some duties, so they cannot be removed or ignored, like timetable trips. But they are not just vehicle activities. For example, also obligatory to the passengers getting on and off. Of course, the working time of these activities cannot be decreased. We call it the fixed working time, but other activities can be eliminated, and the working time of these activities are the reducible working time. Of course, when we check the solution, the working time is comparing the working time is more reliable to check the reducible working time. Next slide, please. Okay, and next slide, please. Okay. So how we get the reducible working time? We calculate the fixed working time. Of course, it is really hard to get the exact value of the fixed working time. We should solve the original problem optimally. So it's not an option. So we just estimate the fixed working time with a lower bound. The activities which gives the fixed working time can be grouped into two types. The inner activities are those ones which depend on other activities and connect to them. For example, the passengers getting on and off, which is connected to the timetable trips. The duty activities, those ones which only depend on the duty. For example, the checking in at the beginning and checking out at the end of the duty. And we estimate both the working time of both types. Next slide, please. So the inner activities, we reduce the original problem to a single commodity network flow problem, which can be solved in polynomial type. Of course, the result is just a lower one for the original problem. We build a connection-based network flow model. When nodes are the tasks, edges are the connections between the tasks, and the weights come from the minimum working time between two activities. And as I said, we can solve it efficiently with the solver. Next slide, please. The working time of duty activities. So we try to calculate the minimum number of duties in a day, and it is not equal with the maximum number of trips in each minute. So how we calculate it? We define a time window, because a time window capital I, because there is a maximum length of duties, and there is two other time window, A before I is A and after I is B, and we can calculate the minimum number of duties in a time window with a simple network flow problem, and we can calculate the minimum number of duties with this I is as a maximum I and A and NB, because a driver cannot work in B if he or she works in A. And of course, then we shift I through the day from the beginning to the end, and the maximum number of duty in each iteration. We got the minimum number of duty in that day. Next slide, please. So how is this process? As an input, we got the timetable, and if a vehicle scheduling is already solved before the driver scheduling, we solve it, and the activities are added to the trips, and then we build the connection-based network graph, and we calculate the minimum number of duties, and then we give this value to the weighted graph, and then we calculate the connection based with this weighted graph, and the results is the lower bound for the working time for the original problem. And next slide, please. And finally, just an example where we tried this problem. We tried with the Szeged, is a middle-sized city in Hungary, with different date times, and we test an algorithm called cut and join. And the result is where we first evaluate this problem. We found that the improvement was only 3%. We compared our results to the schedules of the local bus transportation company, and we found that the improvement was only 3%, which was not so good. But then we calculate the reducible working time, the fixed working time, and the reducible working time, and found that the reducible working time was only 10% than the total working time. So there is really small room to improve. And then when we compared our results to the reducible working time, we found that around 20% of the in timetable case and 32% in vehicle scheduling case, with such much more better result. And as a conclusion, that this is a much more reliable and real method to evaluate the solutions and methods in driver scheduling case. No problem. And thank you very much. Next slide, please. Thank you. Any question?
Thank you very much for very interesting presentation. A driver schedules optimization in public transport is a still live problem. Do we have any question to our presenter? We don't see any. Oh, we see one hand. So please.
Full time of the information. Dear colleagues, maybe I contact with you because I'm here in my room, and I carefully listen what to do in your session. Of course, I'm listening another parallel session. And I must say that I call to you and contact with you, first of all, to say welcome to our virtual space, and I'm very glad to meet you in our conferences. One of organizer as coordinator of this conference, how ask and how take part in discussion. You look here that we can have raise hand, and after that put down. And if somebody from you decided to ask some questions to our presenter, this we have the same opportunity. Thank you, and I wish you all the best, all very fruitful participation in our conference. Thank you.
Next slide, please.
Bye.
Thank you, Professor, for explanation. Do we have more question? More question generally, because it was not question, it was explanation. No, we don't have. It's time for the next presentation. The next presentation has a title, An Application of the Analytic Hierarchy Process for Evaluation of Level Crossing Design in a Congested Urban Area. We see a presenter. So, presenter, do you hear me?
Yes, I can hear you. Hello, good morning.
Hello, good morning. We see you, we hear you. So please, time is yours.
Great. Thank you, Mr. Chairman. Today, I would like to briefly present summary of our research, the research which was conducted by myself and my master's student, Antonia Jumbo. Next slide, please. In the presentation, I will point it out on two main parts of our research. First one is HP method, one of the method of multi-criteria decision making, and second one is level crossing points of the traffic network with potentially high risk of accidents. So the main objective of our study was to develop an HP model for evaluating the alternatives for the reconstruction of level crossings. And we tested our model on the case study of level crossing Sokolska in Zagreb. Next slide, please. So let's start with the multi-criteria decision making and the HP method. We analyze a lot of studies, and studies shown that the HP method can be used to solve complex traffic infrastructure problems related to planning, investing in transport infrastructure, including level crossings. So therefore, we use the HP method in our research. HP method is one of well-known methods, so I will not explain the method in details, just a few words. As you know, it was developed by Thomas L. Saty. The first step is to build the hierarchy structure, as you can see on the first picture. So the hierarchy structure includes objective, alternatives, sub-criteria and sub-criteria. Next step is ranking criteria and sub-criteria, then ranking alternatives, selection the optimal alternative, and at the end, the sensitivity analysis to confirm the robustness of the model. Next slide, please. On this slide, you can see the picture of railway network in Croatia and some data about level crossings on our network. So level crossings are points where rail and road are crossed. So that means that these points have high risk of accidents. In Croatia, we have 1,503 level crossings, which 61% have passive protection and 39 have active protection. In the last 10 years, we have a lot of accidents resulting in death, serious injuries, train congestion, material damage. And in conclusion, we know that human factors are the main cause of collision at level crossings. So according to that, we try to build our proposal for new solution for our case study, level crossing Sokolska. Next slide, please. So now I will explain our case study. The study area is in the Zagreb, city of Zagreb, in the western part of the city of Zagreb. This level crossing is located on the international double track railway line for passenger traffic. But on the distance on 22 meters, there is also an industrial track that connects the container terminal only for freight railway traffic. This level crossing is provided by barriers operated by a crossing guard, so it's a very low level of protection of this level crossing. The maximum permitted speed on this section is 60 kilometers per hour, and a total of 226 trains pass through this level crossing daily. Pedestrians, cyclists, motor vehicles move across this level crossing by the area of 7.7 meters, which is not enough for safe traffic. In addition, in peak hour, we have 9 minutes for lower the barriers, which created long queues, both for motor vehicles and for pedestrians. Therefore, we have a lot of problems on this level crossing. Next slide, please. And in this picture, you can see some of the main problems at the level crossing Sokolska. So you can see that pedestrians, cyclists pass under the barrier and cross the track while the barrier is lowered and the train is expected to arrive. Then we have pedestrians who often walk along the railway tracks in order to shorten the journey to the railway station. For example, when drivers notice that the barriers are being lowered, they immediately increase their speed and cross until the barriers are lowered almost to the end. So this often leads to barrier breakage and great big material damage. At night, the lighting is very poor, which makes also level crossing even more dangerous for pedestrians and cyclists. And although this level crossing is in the wider area of city center, you can see on the last picture that maintenance of this level crossing is very poor. Next slide, please. So on this slide, you can see steps of our methodology. We start with analyzing the current situation of level crossing, then collecting, which means collecting data from infrastructure manager, traffic count, surveys, and video surveilling. Then we propose new alternatives for level crossing, which are possible. Then we evaluate the proposed alternative by using HP method and the software expert choice. And then at the end, we made sensitivity analysis also in expert choice software. Next slide, please. About data collection, I will speak probably whole day, but I don't have so much time. So I will just point out a few maybe important things about data collection. So first, we map all locations of level crossing in the city of Zagreb. There are 32 level crossings. We map it in this database. Then we collect statistical historical data from infrastructure manager, HAŽ Infrastruktura. Then we collect other data according to our developed methodology we developed it at the faculty for collecting data for traffic counting, surveys, and video surveilling with our own equipment. And we made surveys and we organized surveys to see how level crossing users behave on the level crossing and how often they choose the level crossing. In general, we want to obtain the data of patterns of behavioral level crossing that significantly contributed to the planning of proposal for our new alternatives for the reconstruction of level crossing. I would just mention maybe one question of our survey. The question was, are you using improperly this level crossing? And interestingly, 84% of respondents said they crossed the level crossing while the barriers are lowered. Only 16 of them are crossing properly this level crossing. Next slide, please. According to collecting data, we propose new alternatives for possible alternatives for reconstruction. So we propose 3 alternatives. First one, alternative 1, the proposed design solution like construction of a pedestrian and cyclist underpass. The construction of an underpass would eliminate the conflict points between road and railway traffic. And in addition, we propose some equipment for this solution. First, installation of new protective fence, installation of anti-stress panels. It is an innovation that prevents pedestrians walking on the track. Installation of new barriers and small changes in the gravitational area of level crossing Sokolska, which means change of direction of some streets, additional horizontal and vertical signalization, and etc. Next slide, please. On this picture, you can see alternative 2. For alternative 2, we propose the construction of an underpass for motor vehicle. That underpass would completely separate road traffic from railway traffic, and traffic safety will be significantly higher. The plan is to build an underpass for pedestrians and cyclists as well. This underpass would be similar like proposed underpass in alternative 1. Also, like we propose in alternative 1 additional equipment, we propose it here as well, some protective fence, anti-trespass panels, new barriers, etc. In conclusion, I can say that this alternative have advantages and disadvantages. Advantage is of such solution is that this solution could maximize the safety of all traffic participants. But main disadvantages of this solution would be the construction of underpass is very demanding and requires a lot of space, and so Sokolska Street is not so wide. And also need to mention that this solution is very, very expensive. The third alternative is also third alternative that we propose is a complete closure of this level crossing. I didn't mention before, but near this level crossing, we have in 350 meters one underpass, and in 1.5 kilometers also next one. So we could use it for the traffic. We could use that underpass, and the Sokolska would still remain open for pedestrians and cyclists. For pedestrians and cyclists. On this slide, you can see HP model. The model was built based on the comprehensive review of the research literature, also existing some field studies or different level crossing cases in Croatia. This model was tested. Also, although the model is tested on level crossing Sokolska, it could be also applied for other level. The model consists of 6 criteria: safety, traffic indicators of functional efficiency, benefits, ecology, and time required for reconstruction. And some of these criteria have sub-criteria, altogether 15. Next slide, please. The big challenge is to build the model and to calculate the importance of the criteria and sub-criteria. And here you can see on this slide the only results of the calculating importance of criteria and sub-criteria. And on the next slide, you will see the results, final results and optimal, please, next slide. Next slide, please. Thank you. And on this slide, you can see the results after performing the entire analysis and evaluation of the alternatives according to each criteria and sub-criteria by using the HP method. So alternative 3 has been proposed as the best traffic solution, including a number of functional traffic solutions to increase the safety and urban mobility of the level crossing Sokolska region. This alternative is followed by alternative 2 and alternative 1. On the last 2 pictures, you can see sensitivity analysis in order to see the sensitivity of alternatives to changing the importance of the criteria. We change the importance of the cost criteria, cost parameters. We increase it from 8.6 to 25.1%. And at the end, after the sensitivity analysis, the best traffic solution still remains alternative 3, but second place is taken by alternative 1. Next slide, please. And at the end, instead of conclusions, I would like to point it out of 5E approach. 5E approach, which means enabling education, engineering, enforcement, and evaluation. We deal in our research only with engineering, but to fully propose the best solution, to reach maximum safety and level crossing, other 4 should be also applied, because there is no one single measure for increasing safety at level crossing, and therefore we need to deal with all these 5 E's. And next slide.
Thank you very much for very interesting presentation. Usually on transport system networks points when we have connection between vehicle traffic, pedestrians and cyclists, it is usually a very complicated point for designing. We don't have time for question to our presenter, but if you have any question, please write this question, because after conference for all participants, we will be sending proceedings. In this proceedings, you will have email address of each presenter, so you can use this email in order to ask the question to our presenter, because now we don't have time for question. Thank you very much once again for your presentation. And I would like to invite the next presenter. Next presentation has a title, Changing Transport Behavior for Sustainable Urban Mobility.
Good morning.
Good morning. We see you, we hear you. Time is yours, please.
Great. Thank you. Thank you very much. First of all, I would like to welcome all participants, all friends, and I would like to say thank you very much for Mr. Professor for having me here and having my presentation. And I would like to thank you all organizing team for organizing this conference, Transport Problems 2021. The conference, which is year to year, is getting bigger and bigger. So my name is Katarzyna Sicińska, together with Maria Dąbrowska-Lawrence from Motor Transport Institute and Aleksandra Jankowska from the Council Office in Łomianki. We would like to present you today presentation on changing transport behaviors for sustainable urban mobility, results from survey in Warsaw West area. Yesterday there was discussed topics related to sustainable urban mobility. Today we will concentrate on more sociological aspect than technical one. Can I have the next slide, please? So the new concept of sustainable urban mobility means that road users go first with more affordable, accessible and healthier, cleaner alternatives. This is an answer to today's negative aspect of road transport with heavy air pollution, noise, traffic congestion and road safety with high number of deaths and serious injury. Plan of today's presentation consists of 14 slides and concentrate on urban mobility strategy with priority of pedestrian and cyclists or more public transport. Because the key pillar of sustainable mobility is green active, not motorized transport of pedestrians and cyclists, I would present you some statistical analysis to high risk of deaths for this group of road users. Then I will characterize the Warsaw West area in which the sustainable urban mobility plan called as a SUMT was developed and introduced. Then findings from the survey on changing transport behaviors for future green mobility. Conclusion and recommendation at the end. The next slide, please. So the European Union strategy on green, cleaner, connected and safer transport by 2050 means shifting to climate neutral Europe with such a document as European Green Deal, Sustainable and Smart Mobility Strategy, which means that all cars will be zero emission, rail, freight will double, speed of rail will triple, and the multimodal network will be more comprehensive with full of digitalization and full of green technology. So the European Union strategy to safer roads is connected with Vision Zero approach. It means no deaths and seriously injured on European roads till 2050. Because the pedestrian and cyclists, they play a key role in sustainable mobility. As we see, they are the most vulnerable road users. 21 of all deaths in European Union, they are pedestrians, and all of total road deaths are cyclists, and this trend is slowly rising. So to make them safe is very important. To eliminate all traffic injuries and deaths from cities by improving safety of pedestrians, is cycling is doing by, for example, lowering speed to 30 kilometers per hour. There was the last initiative promoting the safer speed for pedestrian was the United Nations Global Road Safety Week, and another measure to make cycling and walking separate infrastructure. All we know that cycling and walking is great for health, for environment, and is called not motorized transport, also green or active. The next slide, please. As we can see, risk to pedestrians and cycling on roads in Poland is very high. When you look at the left-hand side, on the bottom line with 27%, it's the share of it's the share of total death of pedestrian in Poland. And if you compare this number 27 to 21 on the picture on the left hand side, you could see that the risk for pedestrian to be killed in Poland is higher, much higher than the average for European Union. When we look at the right-hand side, accidents with cyclists in Poland between 2010 and 2019, we see that the number of accidents in this period of 9 years times increase up to 14%, and number of seriously injured up to 46%. Nice slide, please. This is the administrative division of Poland. We see a map of Poland with at the heart of the map is the Mazovian voivodeships line with the yellow border line. The Mazovian voivodeships is divided into 37 counties. As we can see, the map of Poland is almost red. It means that the risk of deaths on road in all communities in all voivodeships in Poland is very high. The next slide, please. And now we are going to the main subject of today's presentation on Sustainable Urban Mobility Plan. This is the European Union strategy for greener, healthier, safer and affordable transport. Some address issues such as safety, urban infrastructure, especially for vulnerable road users, the use of modern technology for better urban road safety, traffic rules, enforcement, and road safety. And with the doing and introducing this plan, very important is engaging residents, citizens to participate in the process, to have their support, and in the end change their awareness for green transport. This kind of plans are rather popular for big cities like London. Warsaw, for example, have its own sustainable urban mobility plan. It is called City Partnership Initiative. But what is quite unique and exceptional is developing this kind of plan covering urban-rural areas outside metropolis. A good example of it is a sustainable urban mobility plan for Warsaw West functional area, covering the area of 7 municipalities. This is the pilot study in Poland, which is going to finish this year, financed by European Union for integrated territories and investment. The next slide, please. So the other more characteristic of the Warsaw West area, functional area, is that it consists of 7 municipalities. It's located in 3 countries, close to the big town of Warsaw, capital of Poland. So the inhabitants of this area mostly travel to work to Warsaw, but they rest, have family life, they houses outside city, outside Warsaw, in rather urban, rural areas where there is a big urbanization and distant places where the mobility is getting a very important issue. So the plan for SUMT is just to integrate the large area of 7 community, to develop one single sustainable urban mobility plan for then carry out survey to find out how the people travel today and find their willingness to change their preferences in the future, and put the results from the server into the local document to transform the area and change at the end mobility behaviors. The next slide, please. So the survey on old and future transport behaviors were carried out between 18 February and 8 March this year. Took part 177 respondents due to the COVID pandemic situation. The methodology used in this survey, there was the online questions related current commuting habits to specific means of transport, car, bikes, train, public transport, and the problems residents face while traveling in single municipalities on short travel and from one to another. So the expectation for better urban mobility, scoring of transportation system of the area, their preferences, their willingness to change, their preferences and aim of traveling. Respondents mainly came from big cities. They were rather employed people, well educated, between 26 and 45 years old. Car in 95% were in their households. The next slide, please. So the first question was, how often during the last 3 months did you travel? And there was different modes of transportation. Car. We see that this slide presents the survey on mobility habits while traveling on short distances in one municipality. So the residents, they like to travel by car, but they didn't travel by public transport at all. So as far as green transport, walking and biking is concerned, the people like to cycling and traveling on foot in one municipality. Can I have the next slide, please? And survey on today's use means of transport by traveling on long distances indicated that it's quite popular to travel in passenger car as a passenger to when somebody give me a lift. So this is quite popular. Walking or cycling is not popular at all, as the people didn't travel using their own car, traveling from one to another community. The next slide, please. So the results from survey on today's mobility habits indicate that citizens of Warsaw West functional area, they're traveling on foot and bike. It's quite popular on short distances, but it's not popular when traveling from one to another on long distances. They traveling by car in single municipality, but traveling as a passenger in somebody's car is more popular when traveling on long distances. They don't travel by public bus at all, even or short on long distances. What does it mean? That it indicates, the results indicate that there is a shortage of safe urban rural infrastructure for pedestrian and cycling traveling long distances. There is no reliable service of public transport across the whole area of these 7 municipalities, and there is this high car dependency when traveling on short and long distances. So we like to travel, it doesn't matter if there is a short and on long distance. So 22% of respondents scored transport system as a good. Mostly they travel because of the shopping, work, or seeing relatives reasons. The next slide, please. And this is, we are coming to the main point of our presentation. So there is the answer of our question from the title: if the people, how are they willingness to change old habits and choose the green sustainable transport in the future. So 17% of respondents will not going to change the old habits, but 83 are happy to do this, but under some condition. 14% of them will choose public transport if there will be more reliable with priority bus lanes to Warsaw. 9 of them will be more attractive. If the public, they will choose it with the public transport will be more attractive with more services. Almost 40% they will choose transport public if there would be more diverse system with hubs of different models of transportation like subway, rail, tram, and 18% of them if there would be more dedicated infrastructure, safe infrastructure for bikers with more paths and roads for bicycle and more city bike station. The next slide, please. Recommendation of the survey is a great, it will be a great asset for working document of the plan. And if the document will be well prepared, the Warsaw West area will be developed as an integrated multimodal transport network with diversity of transport modes between all levels of mobility across in one community, across all communities, and between capital and the rest of the area. So the plan should develop future coherent system with more public transport, diverse alternative, and safe, dedicated infrastructure for more active and green mobility. What is very important, making any changes in transport system, you have to support, to have support, the public support of the public, and building social awareness and support is a key issue in the process of changing for green mobility in the future. The next slide, please. So this is the end of my presentation, and the next slide, please. This is the end of my presentation. I'm happy to answer your question, and thank you for your attention. Thank you for having me here, and I wish you all the best and good luck for the conference. Thank you.
Thank you very much for very interesting presentation. Unfortunately, we don't have time now for direct question, but if any of you have any questions, so please, you have to please write an email to our presenter. Thank you very much.
Thank you.
Now we invite the next presenter. The next presentation has a title, A Speed Analysis and Modeling in the Area of Pedestrian Crossings.
Halo, dzień dobry, czy się słyszymy?
Yes, we hear you. We see your presentation, so please, time is yours.
Dziękuję bardzo. Prezentacja będzie poświęcona analizom prędkości w otoczeniu przejść dla pieszych. Następny slajd, proszę. Mówiąc o... Następny slajd, proszę. Mówiąc o prędkości w otoczeniu przejść dla pieszych, nie sposób oczywiście nie wspomnieć o samym bezpieczeństwie pieszych, czy ogólnie rzecz ujmując niechronionych użytkowników dróg. W Unii Europejskiej odsetek ofiar śmiertelnych wśród pieszych waha się na poziomie około 20% i na przestrzeni wielu lat, tak jak widzimy tutaj na tym slajdzie, pozostaje w zasadzie niezmieniony. Następny slajd, proszę. Podobnie wygląda sytuacja w Polsce, z tym, że odsetek ofiar śmiertelnych wśród pieszych jest bliższy 30% i w ostatnich kilku latach, jeśli byśmy wykazali się dobrą wolą, to możemy stwierdzić, że widzimy lekką, delikatną tendencję spadkową w tym względzie. Niemniej należy powiedzieć, że w cudzysłowie być może rekompensujemy to niestety zwiększoną liczbą ofiar śmiertelnych wśród rowerzystów. To, co słyszeliśmy w poprzedniej prezentacji, gdzie też zostało to wspomniane. I tutaj ogólny odsetek ofiar śmiertelnych wśród niechronionych użytkowników dróg w Polsce sięga około 38 do 40% i w zasadzie mimo wielotorowych działań, różnorodnych działań podejmowanych w kierunku poprawy tej sytuacji, poprawy bezpieczeństwa pieszych, mamy ten odsetek pozostający na tym niezmiennie jednak wysokim poziomie. Następny slajd, proszę. Kolejnym niepokojącym problemem jest liczba wypadków rejestrowanych na przejściach dla pieszych, a więc w miejscach, które są teoretycznie bezpieczne czy bardzo bezpieczne dla niechronionych użytkowników dróg w momencie przekraczania jezdni. I tutaj, gdybyśmy wyłączyli z rozważań lata 16-18, kiedy nastąpił jakiś gwałtowny wzrost liczby wypadków na przejściach dla pieszych, to na dobrą sprawę w ostatniej dekadzie, w minionej dekadzie moglibyśmy powiedzieć, że następuje lekka, ale jednak tendencja wzrostowa, jeśli chodzi o rejestrację wypadków na przejściach dla pieszych, co jest na pewno niepokojące znów w kontekście tych różnorodnych działań zmierzających do poprawy bezpieczeństwa pieszych. Następny slajd, proszę. Tutaj widzimy kolejny niepokojący w zasadzie fakt związany z bezpieczeństwem pieszych, przekładający się na tą na pewno wysoką liczbę i ofiar śmiertelnych, i poszkodowanych wśród pieszych. Mamy tutaj ten ciągły, w zasadzie na przestrzeni ostatniego dziesięciolecia nieustający wzrost, jeśli chodzi o udział wypadków z pieszymi, do których dochodzi na przejściach dla pieszych. I widzimy, że w ostatnich latach ten udział wypadków osiągnął już prawie w zasadzie 50%. Następny slajd, proszę. I teraz jeśli połączymy tą dużą liczbę wypadków czy zdarzeń drogowych, do jakich dochodzi na przejściach dla pieszych, z główną przyczyną, a ta główna przyczyna zgodnie według statystyk policyjnych wieloletnich pozostaje także niezmienna, bo jest to nadmierna prędkość, więc jeśli połączymy tą dużą liczbę wypadków z prędkością i przyjrzymy się temu wykresowi pokazującemu prawdopodobieństwo śmierci pieszego w zależności od prędkości, z jaką zostanie uderzony, to widzimy, że tutaj nawet na tym wykresie to prawdopodobieństwo przy tym limicie prędkości ogólnym w terenie zabudowy 50 km na godzinę, to prawdopodobieństwo wynosi około 40–50%. Przy czym są opracowania z innych krajów podobnych modeli, gdzie to prawdopodobieństwo przekracza 60, a nawet 70% przy tym limicie 50 km na godzinę. Następny slajd, proszę. I teraz kwestia tej prędkości w rejonie przejść dla pieszych jest istotna, ponieważ tak jak pokazują wyniki badań, które miałem przyjemność prezentować na konferencji ubiegłorocznej, niezależnie od lokalizacji przejścia dla pieszych, czy będzie to przejście dla pieszych zlokalizowane na odcinku jednojezdniowym, czy na odcinku dwujezdniowym, czy będzie to przejście zlokalizowane w obszarze skrzyżowania, czy na odcinku pomiędzy skrzyżowaniami, z jednej strony średnie prędkości, jakie były rejestrowane na przejściach, każdorazowo są wyższe od istniejącego lokalnego limitu prędkości. Z drugiej strony, co jeszcze bardziej niepokojące, a co obrazują te kolorowe kropeczki, odsetek kierowców przekraczających prędkość właśnie na przejściach dla pieszych. I generalnie ten odsetek waha się, jak widzimy, zasadniczo od 80 do 100%. Mimo że w większości będą to niewysokie przekroczenia prędkości, to jednak przytłaczająca większość nas, kierowców, porusza się w rejonie przejścia czy na samym przejściu dla pieszych. Mówimy o przejściach oczywiście bez sygnalizacji świetlnej, z prędkością powyżej istniejącego limitu. I znów, jeśli pomyślimy sobie o tym wykresie prezentującym prawdopodobieństwo śmierci pieszego w wyniku zderzenia przy odpowiedniej prędkości, to widzimy, jak niebezpieczna jest ta sytuacja. Podejmowane są oczywiście różnorodne działania w celu zarządzania tą prędkością w rejonie przejść dla pieszych. Bardzo często jest taki najprostszy środek stosowany przez zarządców dróg, gdzie wstawiane jest lokalne ograniczenie prędkości i to jest całkowicie nieskuteczny środek. To jest uzupełniane na drogach niższych kategorii coraz częściej i zapewne bardzo dobrze, bo jest tego jakiś efekt pozytywny wprowadzaniem fizycznych środków uspokojenia ruchu drogowego. Pytanie jednak, czy możemy w inny sposób kształtować skutecznie prędkość w rejonie przejść pieszych, niekoniecznie stosując właśnie fizyczne środki uspokojenia ruchu. Następny slajd, proszę. W tym celu przeanalizowałem prędkości pojazdów na kilkunastu przejściach dla pieszych zlokalizowanych w Białymstoku i znów przejścia zlokalizowane były na odcinkach jedno- i dwujezdniowych i zróżnicowane były między sobą z uwagi na ich parametry, podstawowe parametry geometryczne i do tego jeszcze położone były na odcinkach z różnymi lokalnymi ograniczeniami prędkości. Następny slajd, proszę. Wstępna analiza średnich prędkości pokazała znaczne i istotne różnice pomiędzy średnimi prędkościami zarówno w grupie przejść położonych na odcinkach dróg jednojezdniowych, jak też w grupie przejść na odcinkach dwujezdniowych. Następny slajd, proszę. I w kolejnym kroku podjęta została próba opracowania modeli regresyjnych opisujących zmienność prędkości właśnie na przejściach dla pieszych w zależności od tych podstawowych parametrów geometrycznych przejść dla pieszych. W tym celu została przeanalizowana istotność wpływu wybranych parametrów geometrycznych przejść położonych na odcinkach jednojezdniowych, takich jak szerokość pasa ruchu, długość przejścia dla pieszych, pomijając też oczywiście limit prędkości, a w przypadku przejść położonych na odcinkach dwujezdniowych, dodatkowo oprócz szerokości pasa ruchu i całkowitej długości przejścia, wzięty pod uwagę został parametr określający szerokość pasa dzielącego. I w pierwszej kolejności sprawdzono istotność wpływu tych poszczególnych parametrów, gdzie analiza wariancji wykazała, iż każdy z tych parametrów indywidualnie jest istotny, jeśli chodzi o wpływ na prędkość. W związku z tym te parametry były wykorzystywane do stworzenia modeli regresyjnych właśnie opisujących podstawowe parametry prędkości na przejściach dla pieszych. Następny slajd, proszę. I w wyniku przeprowadzonych analiz udało się opracować modele regresyjne, liniowe, opisujące prędkość średnią i kwantyl 85% prędkości. I w przypadku przejść położonych na odcinkach dróg jednojezdniowych, oprócz limitu prędkości istotnym parametrem okazała się tylko szerokość pasa ruchu. Niemniej przy wykorzystaniu tych dwóch parametrów udało się stworzyć model, opracować model, który dobrze opisuje zmienność prędkości na przejściu dla pieszych. W przypadku kwantyla 85% mamy poprawiony R² o wartości 0,62, a w przypadku średniej prędkości mamy 74% zmienności wyjaśnione tylko przez te dwa parametry. Następny slajd, proszę. W przypadku przejść zlokalizowanych na odcinkach dwujezdniowych dodatkowo istotnymi parametrami, które zostały wykorzystane w modelu, oprócz istniejącego lokalnego limitu prędkości i szerokości pasa ruchu, okazała się także szerokość pasa dzielącego oraz całkowita długość przejścia dla pieszych. I tutaj doszły te dwa dodatkowe parametry jako istotne do modelu, ale też dzięki temu okazuje się, że tak skonstruowane modele wyjaśniają nam prawie w 100% zmienność prędkości na przejściach dla pieszych. Czyli mamy w zasadzie proste narzędzie do tego, aby móc ocenić prędkość pojazdów na przejściach w zasadzie zawczasu, w zależności od tego, jakie parametry zostaną wykorzystane. Następny slajd, proszę. Przechodząc do wniosków, wypadki drogowe mające miejsce w obszarze przejścia dla pieszych stanowią 50% wszystkich wypadków z udziałem pieszych. Nadmierna prędkość jest dominującym czynnikiem prowadzącym do poważnych wypadków drogowych, w których piesi stanowią ponad 20% ofiar śmiertelnych, a w Polsce blisko 30%. Podstawowe parametry prędkości, jak średnia prędkość czy kwantyl 85% w obszarze przejść dla pieszych, istotnie zależą nie tylko od limitu prędkości, ale także od parametrów geometrycznych samego przejścia dla pieszych, takiego jak szerokość pasa ruchu, szerokość pasa dzielącego czy całkowita długość przejścia dla pieszych. Opracowane modele regresyjne wyjaśniające w sumie od 62 do 98% zmienności prędkości w obszarze przejść dla pieszych mogą być wykorzystywane jako skuteczne narzędzie przy projektowaniu bezpiecznych przejść dla pieszych z uwagi na kształtowanie prędkości w ich obszarze. Możemy wnioskować, że niekoniecznie, nie zawsze, też i nie wszędzie możemy zastosować środki fizyczne do uspokojenia ruchu, do wymuszenia na kierowcach poruszania się z bezpieczną prędkością. Tutaj już na etapie projektowania projektanci, mając tą wiedzę, mogą dobierać takie parametry, aby właśnie tą prędkość próbować utrzymywać na odpowiednio niskim poziomie. Następny slajd, proszę. Dziękuję bardzo za uwagę. Jeśli są pytania, to proszę bardzo.
Thank you very much for very interesting presentation. Managing the vehicle speed on the area of pedestrian crossing is very important because the lower the vehicle speed is, the lower the injury of pedestrians. So it is really important problem. Do we have any question for our presenter? We have time for one question. So maybe I ask you, my question is, how numerous sample size was on base you prepare your model?
In case of each pedestrian crossings, the number of vehicles that I took into account, it was around 120 vehicles moving in free flow conditions.
Thank you very much. Thank you very much. If you have more questions, please send email to our presenter. Do we have next presenter? Probably not, but I have to ask. No, because we don't have the next presenter, so we see this presentation.
Hello. Hello. Hello, everybody.
Hello, we hear you. You will be presenter, yes?
Yes, the people of equity of transit need.
We hear you, we see your presentation. Time is yours.
Sorry, not this presentation. The paper of equity of transit need.
It is probably not your time, because now we have time for
Okay.
presentation
Sorry.
and
Sorry.
investigation of factor influencing intra-city mobility, a case of Enugu metropolis, Southwest Nigeria. I ask because I have information that we don't have presenter. You are not presenter for this presentation, yes?
Yes, this presentation is not to me.
Thank you very much for information. So we don't have presenter for this presentation, but we see this presentation without presenter.
Hello. Cannot hear.
Thank you very much. We saw this presentation. If you have any question, please send email to our presenter. Now it's time for next presentation. We know that we have presenter. Next presentation has a title, Equity of Transit Need in Baghdad City.
Hello, everybody.
Hello, we hear you. We see your presentation, so please, time is yours.
Thank you. It is a good opportunity to participate in this conference. This paper is presented by me, Nurmat Ismail, and the author أيضا cooperated Mohamed Qahtan Wahid from Baghdad, Iraq. The title of the paper, Equity of Transit Need in Baghdad City. Introduction: public transportation plays a major role in an urban area to transport a large percentage of people. An urban areas involved many origin and destination with various traffic trends, which in turn result in complex transportation with multiple modes. The only modes in our case study in Iraq, it's by bus only, just the transport by buses. So this is another problem. Transportation as a derived demand is heavily influenced by the environment surrounding and the environment at destination, which lead to the issue of how much access a place is from other location. There is a need to balance between transportation demand and supply and to conduct service equity analysis before implementing any major service. A problem definition in our country is the population of the country is increased, which with the stable with the use of bus transport. This is a huge problem in our country, so we need public planning. Public transit planning must be accomplished in an effective, advanced, and comprehensive way to make the please. Next slide, please. So we need public transit planning in an effective, efficient, sustainable, and profitable. In recent years, in Baghdad City, increased its population growth, accompanied by high car ownership, reached 3.5%, which make the transport across the city had long travel time with high congestion in many areas. The development of the various economic activities section in this sector in this area and the presence of major facilities have led to significant travel need. There is major traffic, there is major economic activities appeared in all the area. So we need travel needs. So we need public transport planning. Public transport, which is presented slowly by buses, need to be investigated its accessibility to various zones in the country. Next slide, please. Methodology of the study in this research, geographic information system and the spatial multi-criteria analysis are used, which are presented by AHB to develop systematic technique in public transit planning to maximize the effective service area and population need and travel need and serve the most transit supportive area, thus making the service more sustainable. This methodology investigates an accessible area and try and improve public transit planning through the development of a transit suitability map, consists of a GIS analysis concerned with the transit need, accessibility, and equity. This paper is intended to assess public transit equity by applying a spatial accessibility index. Next slide, please. Data collection, the existing public transport network, which defined the transport supply along the entire study area, was defined using the field survey using GPS device. All data were paired in GIS with version 10.8. The following layers were built in the GIS environment, which consists a layer of highway network with all its attributes, and a layer of public transport network, which with all its attributes. All these data were geocoded in GIS. The network was represented by link and node, and in public transport node is represented by bus stop, and in GIS related all attributes by their length, type, and time, or all it is coded to this layer. In addition to the above geodatabase, the following data were collected from various agencies in Baghdad, which include the income over city, income for each zone, commercial center across the city, education facilities location across the city, and hospital location, and the land use of the city, and public terminal point and stop. All these data were created using GIS as shown in the following image. Next slide, please. This image, as you shown, it is created by GIS Environmental, which include map for bus terminal, map for bus stop, map for land use, map for population density across the city, and map present the commercial center location, and another map show the educational and hospital location across the city. All these maps were created in GIS and will be used to present the transit need map for the city. Next slide, please. Model builder in ArcGIS is used to build the transit need map. So the output of our paper is the transit need map, which represents the need across the city, the travel need across the city. So all these data, or these criteria were collected, and so the AHB is used to find the weight of a criteria. So a questionnaire is designed and given to the decision maker to give their opinion about balance between different criteria used. So as shown in the following table, show the result of the using AHB. As you shown, the income, population, and education is the higher weight, 20. Than other criteria. These weight were used in model builder to weighted all data and to create transit need map. Next slide. As shown in the following map, as in the following figure, it is shown the model builder, which is used to create a transit need map. As shown, it is use point density, line density. It is use weighted sum, reclassify tool. All these tool is used to create weighted map. Next slide, please. As shown in the following table, we show the transit need map. Next slide, please. Next slide. It is appeared that area with the blue color, this is the output of a model. We show the area with the blue color experience high or highest level of a transit need in the area. So due to these results, it is appeared that area with high transit need must provide with high transit capacity, such as metro, where the area in this city or in this map, the area with orange color, area with orange color is lower travel need and must provide with light rail transit to meet the mobility need of the region. Due to high population of Baghdad city, especially in Sadr city, Kadhimiya, Shu'la, and center of Baghdad, this place must provide with high capacity transit routes such as metro, as shown in the blue color. Blue color area, it is the mean high travel need. Also, existing public transport needed to raise its efficiency by existing public transport in the city, it is just by buses. It is need to raise its efficiency by providing modern buses with high capacity, given a priority in an intersection, locating specific stop along route. This is the to raise the efficiency of existing public. But we need another mode to use in our area because of high travel need. Our transit supply will overlaid with the transit need map, which is created. So transit equity is measured by the difference between transit need map and the transit supply map. It is appeared that area around the downtown area is quite transit accessible because public transit routes are laid out in a way that can connect CBD with, which is a major activity in the city, with other locations to maximize the accessibility and ridership. Next slide, please. Conclusion, the main point concluded are following. The transit need map was generated using GIS spatial analysis based on maximizing the population need. The output of this study can be used by decision maker to establish a transit alternative and prioritize transportation project. From the transit need map, it appears high important area where was suggested to provide it with high capacity transit like metro to maximize the transport efficiency. Thank you for listening.
Thank you very much for interesting presentation. Do we have any question to our presenter? If not now, maybe later you can send to our presenter email with question. So we can start the next presentation. Next presentation has a title, A Human Factor in Cyclist Safety, Results of Survey. Do we have presenter?
Yes, I am.
Thank you very much. We hear you. We see your presentation. So please, time is yours.
Thank you. Hello, everybody. I would like to present the results of survey concerning cyclist safety. The presentation was prepared in English, but will be delivered in Polish. Proszę o następny slajd. Pojazdy dwukołowe mogą znacznie wpłynąć na rozwiązania problemów zagęszczenia ruchu drogowego w centrach miast, zwłaszcza w podróżach na krótkich dystansach. Analizując problem użytkowania pojazdów dwukołowych w wielu krajach, można dojść do wniosku, że największą obawą użytkowników jest właśnie obawa o bezpieczeństwo, a właściwie zagrożenie ze strony innych użytkowników ruchu, zwłaszcza samochodów. Liczba ofiar wypadków w przeliczeniu na 1 kilometr pokonanego dystansu jest dla rowerzystów bardzo niekorzystna, ale już jeżeli odniesiemy liczbę ofiar do liczby rozpoczętych podróży, to ta proporcja właściwie jest taka sama, jeśli chodzi o rowerzystów i innych użytkowników drogi. Tutaj mam na myśli głównie zmotoryzowanych. Następny slajd, proszę. Panuje obiegowa opinia, że używanie rowerów w Polsce jest bardzo niebezpieczne w porównaniu z innymi krajami. Jednak wszystko zależy od podejścia statystycznego. Otóż przedstawione dane pokazują, że no być może aż tak tragicznie nie jest, ale należy też pamiętać o tym, że im większa liczba rowerzystów, tym potencjalnie rzecz biorąc jest większe prawdopodobieństwo, że liczba ofiar będzie w odniesieniu do liczby mieszkańców większa. Następny slajd, proszę. Prezentowane dane statystyczne mogą być obarczone błędem, ponieważ opierają się wyłącznie na danych z raportów policyjnych. Natomiast z praktyki wiadomo, że w przypadku zdarzeń drogowych dochodzenia prokuratorskie lub dochodzenia sądowe mogą być czasami, rezultaty tych dochodzeń mogą być czasami odmienne. Najwięcej kolizji z rowerzystami spowodowali kierowcy samochodów osobowych. Liczba poszkodowanych rowerzystów jest właściwie równa liczbie kolizji, czyli rowerzysta w kolizji z samochodem praktycznie nie ma żadnej szansy, żeby wyjść bez szwanku. Zawsze ta kolizja kończy się dla niego źle. Szczególnie tragiczne natomiast są kolizje z samochodami dużymi. To po prostu wynika raz z masy, a widoczne jest to na proporcjach. Ilość kolizji, ilość wypadków w stosunku do liczby ofiar śmiertelnych. Następny slajd, proszę. Główną przyczyną kolizji spowodowanych przez innych użytkowników drogi, czyli nierowerzystów, jest nieudzielenie pierwszeństwa przejazdu. Być może wynika to z nagminnego lekceważenia rowerzystów jako pełnoprawnych uczestników ruchu drogowego. Następny slajd, proszę. Interesującym jest, że taka sama przyczyna dużej liczby wypadków występuje w przypadku kolizji spowodowanych przez rowerzystów, a zatem wydaje się, że to lekceważenie i właściwie nieprzestrzeganie zasad ruchu drogowego jest obopólny zarówno po stronie rowerzystów, jak i po stronie innych uczestników ruchu. Następny slajd, proszę. Większość kolizji spowodowanych przez rowerzystów miała miejsce przy dobrych warunkach pogodowych. Prawdopodobnie są dwie przyczyny. Po pierwsze, dobre warunki pogodowe sprzyjają wykorzystaniu roweru jako środka transportu, ale z drugiej strony także dobre warunki pogodowe sprzyjają zachowaniom ryzykownym i nieracjonalnym. I to nie tylko jeśli chodzi o rowerzystów, ale także można to zaobserwować w przypadku użytkowników samochodów. Następny slajd, proszę. Interesujący jest fakt, że najwięcej kolizji występuje w maju u progu sezonu wakacyjnego. Zresztą taka sama zależność występuje przy analizie kolizji z udziałem motocyklistów. Być może wynika to po pierwsze z braku przyzwyczajenia rowerzystów do warunków drogowych po przerwie zimowej lub także poprawą pogody w Polsce w miesiącach późno wiosennych. Następny slajd, proszę. Najwięcej sprawców wypadków w gronie rowerzystów osiągnęło wiek 60+. I jest to prawidłowość, którą można zaobserwować w innych krajach. My pod względem proporcji zbliżamy się, właściwie jesteśmy w grupie tej, w której znajdują się Skandynawowie. Takie same wyniki odnotowano w Finlandii i w Szwecji. Ogólnie, jeśli chodzi o Europę, ten procent jest troszeczkę niższy. Następny slajd, proszę. Przeprowadzono badania ankietowe wśród rowerzystów. Wykorzystano do tego celu internet, media społecznościowe. Zresztą tego typu badania prowadzone są systematycznie od 5 lat. Ankieta dotyczyła pytań związanych po pierwsze z utrzymaniem roweru, z dbaniem o jego stan techniczny, częstotliwością wykorzystania roweru jako środka transportu i przestrzeganiem zasad, ogólnie zasad bezpieczeństwa w ruchu drogowym. Między innymi używanie także kasków ochronnych. Najwięcej respondentów, którzy odpowiedzieli na prośbę o wypełnienie ankiety, było w wieku 18-30 lat. Warunkiem brania ankiety pod uwagę była deklaracja pokonywanej przez rowerzystów pokonywanego dystansu minimum 50 km miesięcznie. Następny slajd, proszę. Respondenci pochodzili z miejscowości o różnej gęstości zaludnienia. Wyniki analizy ankiet nie są zbyt korzystne dla rowerzystów. Słuchanie muzyki, używanie telefonu komórkowego, jazda bez hełmu, bez kasku ochronnego, jazda po spożyciu alkoholu lub po narkotykach nie należały do rzadkich przewinień. Co ciekawe, 50% respondentów deklarowało, że uczestniczyło w wypadkach drogowych. Tutaj być może ten udział w wypadkach drogowych skłonił ich do pozytywnego oddźwięku na prośbę o wypełnienie ankiety. Być może sami dostrzegli problem użytkowania roweru w ruchu drogowym. Następny slajd, proszę. Jak wygląda ocena infrastruktury drogowej przez rowerzystów? Otóż wbrew oczekiwaniom rowerzyści dość pozytywnie ocenili infrastrukturę drogową. Być może wynikało to z faktu, że większość z respondentów mieszkała w miastach o średniej i dużej wielkości. Stosunkowo mały odsetek ocenił stan infrastruktury drogowej, infrastruktury rowerowej jako bardzo zły. Następny slajd, proszę. Także pozytywnie zostało ocenione bezpieczeństwo rowerzystów na naszych drogach. W tym przypadku jednak wyniki ankiety nie korespondują z analizą danych statystycznych. To znaczy być może respondenci zbyt optymistycznie podchodzili do możliwego zaistnienia niebezpieczeństwa w ruchu drogowym. Następny slajd, proszę. Jakie wnioski można wyciągnąć zarówno z analizy danych statystycznych, jak i z przeprowadzonych badań ankietowych? Otóż nieprzestrzeganie podstawowych zasad ruchu drogowego, to nieudzielenie pierwszeństwa przejazdu i także wzajemna niechęć, agresywność użytkowników zarówno rowerów, jak i samochodów względem siebie są głównymi przyczynami zdarzeń drogowych. Niestety jazda po alkoholu i narkotykach, używanie telefonu komórkowego, jazda w słuchawkach to główne grzechy rowerzystów. Wydaje się, że ten odsetek, no powiedzmy, rowerzystów, którzy nie stosują się do zasad ruchu drogowego, jest niestety większy niż odsetek wśród użytkowników samochodów. Ryzyko odniesienia poważnych obrażeń przez rowerzystów zależy między innymi od infrastruktury, czyli no, separowania ruchu rowerów od ruchu samochodów. Zmniejszenie ryzyka wystąpienia poważnych uszkodzeń ciała lub wręcz wystąpienia ofiar śmiertelnych, wydaje się, jest możliwa poprzez zastosowanie tak zwanego efektu skali, to znaczy im więcej rowerzystów będzie pojawiało się na naszych drogach, tym należy przypuszczać, że ta procentowa liczba ofiar być może zmniejszy się. Będziemy mieli tutaj do czynienia, co możemy zaobserwować w krajach skandynawskich, ale także w Holandii, z tak zwaną masą krytyczną. Po przekroczeniu pewnego progu użytkowania rowerów tych ofiar jest znacznie mniej. Następny slajd, proszę. Dziękuję Państwu za uwagę. Jeżeli byłyby jakieś pytania, to bardzo proszę na maila. Dziękuję bardzo.
Thank you very much for interesting presentation. Human factor in cyclist safety is very important, but also the road infrastructure for cyclists decide also about the cyclist safety, so it is another important factor. Do we have any question to our presenter? We don't see, so maybe later you can ask our presenter, sending him email. Thank you very much once again for interesting presentation. And we invite the next presentation. Unfortunately, we don't have presenter, so we see the presentation without presenter.
Dear conference organizers, dear participants, my name is Andrei Gulic, and I am a research fellow at the Urban Planning Institute of the Republic of Slovenia, located in Ljubljana, the capital of Slovenia. The title of my presentation and my paper at the same time is Methodology for Determining the Types of Business Zones in Slovenia, the role and importance of the transportation accessibility criteria. The article is based on the results of the recent project Methodology for the Inventory of Business Zones in Slovenia, which purpose was to contribute to solving current problems in promoting the development and spatial allocation of business zones and their sustainable and effective management. My article is divided in 4 parts. First, the introductory part, then description of the methodological definitions and steps for classifying business zones. Then I will proceed with the description of the criteria on transportation accessibility of the business zones, and will end with some of the conclusions. Allow me to say, first of all, that the basic problem which we addressed in the mentioned project and also in this article, is the lack of an appropriate and time-adjusted management strategy in the field of business zones. Slovenia has a large number of different zones with different names, different contents and sizes. All this contributes to the fragmentation and disorganization, as each municipality, as a good manager, strives to establish a business zones in its area, even if it does not have an appropriate spatial, infrastructural, business, organizational, and human capacity. All this affects the irrational and unsustainable organization of space and the increase of negative impacts on the economy and the environment caused by irreversible loss of available land, increased passenger and freight transport, energy use, and irrational investment in land development. In the article, we under the term criteria, we define the elements or conditions for the development of business zones. The criteria represents selected values that describe the concept of sustainable development of business zones and can be described by the indicators. Under the term indicators, we define variables that enable the measurement of individual dimensions of the criteria. The criteria and corresponding indicators were classified in two groups, into the group of so-called pull factors and into the group of push factors. Pull factors are factors that attract potential investors to buy or rent building land in an existing or planned business zones in a particular area. And on the other side, the push factors are factors that inhibit or prevent potential investors from purchasing or renting building land in an existing or planned business zones in a certain area, mainly due to the environmental protection requirements and the sustainable use of the limited natural resources. Table 1 presents a set of 11 criteria to which weights were added based on the author's expert assessment. We used weights to express the relative importance of criteria and indicators. And as you can see from this slide, the most important criteria are the cost of purchasing and renting land in a business zone and their management cost. But at the second position, of the most important are transportation transportation accessibility of business zones. For each business zones included in the information system of our projects, and for which the planned quantitative and qualitative data were obtained, considering the prepared set of criteria and indicators for both groups of factors considered, the calculation of push and pull effects of the use of business zones areas for potential investors are performed. In this slide, you can see the so-called push factors. We have defined 13 push factors. And as I said before, all these factors are more or less of natural protection performers. For example, the problem of interference of a business zones with flood areas or with erosion areas or with potential landslide areas and so on. The suitability of land for a business zone is calculated in such a way that from the total sum of the effects of the pull factors of the business zone area, the total sum of the effects of the push factors is subtracted. The result of the calculation are then further normalized to make it easier to classify them into individual types of business zones. In this way, Indicative data on suitability of land for business zones are obtained in the most objective way possible. Data on the suitability of land for business zones are then distributed according to the degree of suitability by 12 statistical regions. For each region, a quantitative weighting indicator is defined, which is related to the development deficiency index, which the region showed in the year 2011. Data on suitability of space for business zones are then multiplied by the weight values of the indicators. In this way, the importance of land for business zones is calculated. The causal relationships between the pull factors, push factors, suitability and importance of land for business zones and the typology of business zones are schematically presented in this figure. Business zones are classified according to the importance of land into 4 types of business zones. Business zones of national importance, regional importance, of intermunicipal importance, and of local importance. Please allow me to proceed now with the most important criterion. This is the criterion of transportation accessibility of the business zones. As I said before, this criterion is one of the most important criteria that affects the attractiveness, so-called pull factor, of a particular business zone for domestic and foreign investors. It is a compositing criterion that contains several sub-criteria. For example, distance of the business zone from the motorway and expressway, distance of the zone to the national railway network, distance of the zone to the combined transport terminals, distance of the zone to the nearest public airport for international air traffic. And in addition to the transport infrastructure that enables the transport of goods, it also includes the infrastructure of sustainable transport. Good transport accessibility to individual categories of transport infrastructures has the effect of reducing costs and increasing the productivity of companies, which is in the business interest of the companies. Greater development in use, especially of the railway and public passenger transport infrastructure, has an impact on more sustainability, accessibility, and mobility with positive effects on nature, the environment, and human health, which is at the forefront of our interest. Some selected indicators of the criterion transportation accessibility of a business zones are included in the business zones and subject of the innovative environment-based web reviewer. So those who are interested in the content of this web page are kindly invited to have a look of it. At the moment, we don't have enough time to go in deep and to present the content of this web reviewer. But nevertheless, you are invited to have a look of it. And in this way, potential investors can obtain the first online basic information about the characteristics of the business zones for which they are interested. Let me now go to the conclusions of my presentation. By preparing a methodology for defining criteria for determining the types of business zones in Slovenia, our attention was to contribute to creating conditions for a more transparent and objective verification and determination of suitable areas for planning, equipping, and construction of business zones in Slovenia. The methodology defines the criteria for determining the types of business zones in Slovenia, considering the functional and special aspects and the aspects of environmental protection. In this context, we pay the most attention to the criterion transportation accessibility and the set of its indicators. This is the criterion that is among the most important of all the criteria of the group of pull factors. In the future, the methodology will be meaningfully supplementing, considering on the one hand the express needs of the state and on the other hand the needs of local communities, regional development agencies and other economic entities from domestic and international environment. So thank you very much for your attention. If you have some questions or remarks, please don't hesitate to contact me. On the slide below, you can find my contact details. So thank you very much once again, and I wish you a good work at the conference. Thank you. Bye.
Thank you very much for wishes. Thank you very much for sending us interesting presentation. If you have any question, so please send this presenter this question into email. Now it's time for the next presentation. Next presentation has a title, Modern Trends and Logistic Infrastructure for Transportation and Sales of Agricultural Products. I think that we have presenter.
Yes, I'm here. Hello.
Thank you very much. We hear you, we see your presentation, so time is yours, please.
Okay, thank you. So hello, everyone, and I'm glad to present the results of research entitled Modern Trends and Logistic Infrastructure for Transportation and Sales of Agricultural Products on behalf of Doctor of Economics and Professors Рамбекова Жанара Sabrovich, Doctor of Economics and Professor Sudakpaeva and myself, Mshat Musina. So the next slide, please. The presentation contains an analysis of current state and trends in the development of a network of wholesale distribution logistics centers for agricultural products, the measures and recommendations for the creation and development of logistic facilities in the agro-industrial complex, and the forecast for the demand for the logistic facilities in Kazakhstan. So next slide contains the research objectives, which are fourfold. The next slide, please. Okay, the first is to analyze the dynamics of cargo transportation in Kazakhstan and the Eurasian Economic Union countries. The second is to identify the main problems of the logistics sector affecting the development of trade activities. The third objective is to analyze the prospects and forecast the development of logistic facilities. And the last one is to propose measures to improve logistics in the agro-industrial complex. And next slide, please. So as the relevance of the topic considers is highly important and significant due to a number of problems and negative trends, such as multiple increase in the cost of goods for final consumers up to 5 to 10 times, and increase in the share of shadow rate, more than 50% losses of agricultural products reaching more than 30% by types of goods, and the existing infrastructure, imperfect logistics, poor interaction of participants in the distribution of goods leads to a significant increase in prices. So the next slide, please. As world experience demonstrate, the formation of stable economic ties between producers and consumers in the system of commodity circulation is possible in terms of structural reorganization of commodity distribution channel based on the use of modern information and marketing technologies, as well as transport and logistics systems, the introduction of new forms and progressive technologies in the sales system of agricultural products, modernization of existing food wholesalers. So the creation of wholesale food markets is only the first and necessary stage of restructuring the distribution channels. And in many countries, along with wholesale markets, logistic distribution centers for food and shopping malls have become widespread. And such competition requires modernization of wholesale food markets, improving the quality of services provided by both commodity producers and retailers. Next slide, please. Okay, the review of existing assessment of the Eurasian Economic Union countries by the UN Food and Agricultural Organization showed the following distribution of losses by the main technological operation, including growing, harvesting up to 30%, transportation up to 20%, processing up to 50%, storage up to 30%. And the total losses for certain types of products may attribute to 40 or 50%. So transportation losses dependent on the type of product range from 2 to 20% in the Eurasian Economic Union countries. And in the supply chain, distributors act as the most important link connecting manufacturers with the markets in which the products are sold. Next slide, please. Okay, the research methods include economic analysis and a survey which was conducted with the workers in the agricultural sector, trade workers, as well as transport and logistic companies. The survey involved 31 Kazakhstani companies. The questions were related to the assessment of the complexity and problems when working with transport and logistic companies, trends in the development of logistics, assessment of factors influencing the level of efficiency in logistic processes, opportunities and changes affecting the development of logistics in Kazakhstan, as well as SWOT analysis of commodity distribution system, the structure of cargo of the company, the most efficient logistic processes in the movement of goods, state support in the distribution system of goods, and proposals for improving the system of commodity circulation. So the next slide, please. If we come to the analysis of trends in the development of freight transportation and the state of logistics in the Eurasian Economic Union countries, first table here represents the changes in the volume of cargo transportation by all modes of transport in 2020 as compared to 2019. And as can be seen from the table provided, the largest decrease in the volume of traffic occurred in Kazakhstan and Kyrgyzstan, respectively by 6.61% and 21.6%. It can be concluded that there is a negative trend in the development of transportation in 2020 compared to the previous year. A decrease in the volume of cargo transportation is observed for each type of transport, especially in automobile and pipeline. The next slide, please. So let us illustrate the dynamics of cargo transportation by all modes of transport by months for the period from January 2020 to February 2021 during the pandemic. So figure 1 here represents that it shows that during the pandemic period and the adopted restrictions on the movement of people and transport in these countries, as in many other countries in the world, there was a certain decrease in the volume of traffic. The decrease occurred especially in March 2020, from August to November 2020, then in January and February 2021, as can be seen from the slide. So on the next slide, we can see the table 2, which represents transportation of food cargoes in export and import directions of Eurasian Economic Union member countries by modes of transportation. And the main volume of goods exported in the Eurasian Economic Union member states is transported by sea or river, attributing to 60% of the physical volume of exports, pipeline, more than 20% rail, almost 17% of transportation. And the import of goods is carried out mainly by sea or river, 37.7% of physical volume of imports, road almost 29%, and rail almost at the same level, 29%. So next slide, please. Here we have the figure 2, which represents the dynamics of volume of transport services in Kazakhstan and the share of food products in freight transportation from 2006 till last year, 2020. So as we can see, over the past 10 years, the volume of goods transported by all modes of transport has grown almost 2 times, from 2.1 billion tons in 2007 to 4.1 billion tons in 2018, and freight turnover for the same period increased 1.7 times. Next slide, please. Okay, so in the context of Kazakhstan, there are 4 separate systems that ensure the physical distribution of goods. First is bulk supply chain, which is common for fuels, metals, agricultural products. The second is project logistics supply chain, including equipment and mainly imports. The third is supply chain of mixed goods, including processed products and chemical products, mainly import and domestic shipments. And the last one is supply chain of mixed goods in transit, which is common for processed goods. So along with goods traditionally transported by Kazakh railway to or from Russia and Central Asian countries, more and more goods are transported in transit from and to China and Central Asia. So the next slide, please. On this table 3, we have a logistic performance index in the Eurasian Economic Union countries for 2007 and 2018. As we can see, this according to this ranking, Eurasian Economic Union member states occupy the lower position. And over the 2 years that have passed since the previous study, Kazakhstan has risen in the ranking only by 6 positions and has not yet reached the indicator of 2010, when it occupied 62nd place. So now occupying only 71st place. So one of the constraining factors for the effective development of logistics services market is the weak development of internal logistics of enterprises in the real sector of economy, primarily with state ownership. Next slide, please. So the slide here represents table 4 with the development of services in the transport and logistics sector in Kazakhstan. And as we can see, there is this insufficient level of development in trade and logistics centers, modern format retail chains, wholesale distribution and logistics centers in Kazakhstan. So the minimum standard for providing the population with retail space are not observed. And if we take, for instance, the standard of 187 square meters per 1,000 people, the actual provision for the whole republic is only 141 square meters per 1,000 people, or in other words, only 75% of the minimum requirement. In the North Kazakhstan region, it is less than 40%, in Kızıldağ region, 43%, in Almaty region, 57%, in Jambul region, 58%. And the shortage of retail space leads to inflated rental rates and buyout of retail space, which ends up increasing the cost of organizing retail business and ultimately to inflated prices for food and goods in these stores. So the next slide, please. So the development of a network of wholesale distribution logistics centers for agricultural products. In general, according to the generated database, more than 2/3 of Kazakhstani agricultural facilities are local and small, and the country is characterized by a low density of railway network, less than 6 kilometers per 1,000 square kilometer of territory, which according to foreign experience is not enough for the successful socioeconomic development of the country. And in Kazakhstan now there are 26 transport and logistics centers created during the period from 1998 to 2019, with a capacity of 10 to 1,000 tons per year. And the centers are concentrated in cities and regions. So namely in Nur-Sultan, the capital, we have 6 facilities. In Almaty, we have only 1, in Western region 8, in Northern region 1, in Eastern as well 1. In Southern region, we have 9. And by the end of the next year, it is planned to build 14 transport and logistics centers in the regions. Next slide, please. Okay. According to preliminary data of local executive bodies in Kazakhstan, there are 1,249 units of fruit, vegetable, potato storage with a total capacity of almost 2,000 tons, which is not enough to ensure the storage of manufactured products. And the development of trade and logistic infrastructure by creating a network of wholesale distribution centers will ensure a decrease in losses of agricultural products after harvest, exclude unproductive intermediaries, access of agricultural producers to trade networks, and increase sales of agricultural products both in the domestic market and the export direction. So the next slide, please. So the wholesale distribution centers should be formed in two directions. The first is trade and distribution, and the second is storage. And on the next slide, we have a description of
Hello, do you hear us? Because we stop hear you. Maybe we have problems with connection with you. We have to wait for presenter because we have problem with connection with our presenter. This connection is break.
Ми можемо дати далі презентацію, niech вона лечить.
Thank you very much for advice. We probably have our presenter back, so do you hear
I'm
me?
so sorry. Yes,
No
I
problem.
can hear
We
you.
have problem with connection.
Okay.
So please
Yeah.
start again.
Okay, so here we have the trade-oriented whole distribution centers, and they should be located 20 to 30 kilometers from cities with a large sales market and a favorable geographic location, and their function will be to bring farmers closer to sales markets. And the second type is distribution-oriented whole distribution centers, which are located within the city. And the presence of a customs terminal on their territory will speed up the cargo clearance procedure. So the next slide, please. Okay, so the development of a wholesale distribution center network for sale, storage, processing, and packaging of agricultural products will allow domestic agricultural producers to increase the competitiveness of agricultural products, to increase the share in the food market of Kazakhstan, provide an opportunity to enter foreign markets, increase labor productivity, improve financial conditions. And the next slide, the analysis made it possible to formulate the main functional and technological parameters of the wholesale distribution centers network and typical functional and technological schemes. So the core of the system will be whole distribution centers classified by trading and distribution functionality. They will offer specialized services ranging from storage and processing to product distribution and marketing. And this infrastructure will make it possible to build efficient transport and logistics channels for key areas of product supply. Also, export and import operations will be carried out to the Eurasian Economic Union countries, Central Asia and China, which will expand sales markets. So the next slide, please. Okay, so on the next slide, we have the forecast, which was made on the logistic facilities development in Kazakhstan. And the forecast is based on integration of several forecasting methods, such as expert assessment, the method of pessimistic, optimistic, and probabilistic opinions, economic and mathematical, including extrapolation, time series analysis, non-standard, verbal information. And calculations showed that according to the probabilistic option, the number of logistic centers by 2021 will be at the level of 31, according to optimistic 36, and according to pessimistic 26. So the next slide. So in conclusion, the foreign experience of creating a wholesale distribution system shows that the concentration of enterprises engaged in the wholesale trade of food products in one place has a number of advantages that consumers, agricultural producers, intermediaries, and the state as a whole receive. And the established network of wholesale distribution centers should have a national scale in order to ensure the optimal rhythm of the work of individual regional whole distribution centers, rely not only and not so much on public resources as on the resources and competencies of private companies. And in order to organizationally improve the production and sales system in the agro-industrial complex of Kazakhstan, it's necessary to form an agro-logistical association which would provide international representation in the world food markets, diversify export supplies, and also increase the competitiveness of product in the domestic and foreign markets. So that's all. If you have any questions, yeah, here's the list of references provided as well. Thank you for your attention.
Thank you very much for interesting presentation. We are on time, so thank you very much again. Do we have any question? We don't see any questions, so we are on time, so we can start the next presentation. Next presentation has a title, The Transitional Regime in Discrete Transport Simulation Models.
Good evening to everybody. I'm glad to be here with you all. And today I will present our work, from my part and my team from University Polytechnic of Bucharest, the transitional regime in discrete transport simulation models. Next slide, please. So the activity inside transport terminal is an important component of logistic chain which serve our society. The optimization action made for internal activity inside the terminal have an influence over the quality parameter of the entire logistic chain. So at every level, they are made decisional making process in these terminals. Next slide, please. According to Stikand and other researchers, the decisional problem in case of transport terminal are solved on 3 hierarchical levels. Next slide, please. At terminal design, at the first level, at the base of the hierarchical pyramid, terminal design level can be met a decision about terminal interface with transport network. The experts use actual data and traffic studies to solve decisional problems. The uncertainty exists in this part of the used model. Next slide, please. At the operative planning level are evaluated the technology proposed to be used inside the terminal. So we talk about the storage planning, the equipment assignment or policy for stacking or handling. These one are introduced in the model to obtain the degree of loading, the waiting time, the coolant, and other serving parameters. The decisional problem at this level are solved in a risk condition. Next slide, please. At the peak of the pyramidal hierarchy, at real-time control level, the experts build models to solve decisional problems under condition of certainty. So the allocation of the specific handling equipment and terminal infrastructure component is made using data obtained a prioristic or in real time. Also, the input and exit flow to and from terminals are made using a strict scheduling program for transport network with regulated access, like rail, river, and in some cases for highway or maritime transportation. Next slide, please. The simulation models can be used to record the qualitative and serving parameters for terminal equipment, infrastructure components, staff members, and other elements, and the specific part of simulation related to them. We use it, and in the research area is used, querying theory. Using querying theory, the activity inside the terminals is described through serving station, queue, and serving discipline. Next slide, please. At global level, to obtain the same or very close results when the simulation is repeated, it happens when the expert builds their application for the case of a stationary regime. This simulation method has the advantage of obtaining the same results when it's repeated. Unfortunately, in a real situation, the activity may experience changes in operating parameters. There are vulnerability in the system. So next slide, please. The perturbator factor for a simulation method as vulnerability can change the functional regime from a stable one to a transitional one. Example for perturbator factors for the transport simulation model can be equipment malfunction, variation of the demand, congestion, warm period at the start of the simulation, staff work break period, and some other kind of vulnerability in the system. Next slide, please. To show the impact of a transitional regime, a simulation model is evaluated for a set of transitional regime. Considering a hypothetical maritime container terminal, a simulation model is developed. We use a dedicated software, Arena Rockwell, and with the help of this software, the main activity inside the terminal are introduced in the model using logical blocks. The topological aspect of this hypothetical maritime container terminal are similar with real aspect from one existing terminal. The model is SOCEP container terminal from Constanța Maritime Port in our country. Next slide, please. The model is it's built in correlation with the main handling equipment used to load and unload the container from maritime vessel and for moving this one from two buffer zones. Here in the next table, in the table below in the slide, we see characteristic for resources of this handling equipment. Next slide, please. Here we have in the slide the simulation model topology that is represented using, as I said before, logical blocks, logical structures. Next slide, please. So the stationary regime in this case is considered when all handling equipment, all of them are available. When one of them, when we see a vulnerability or more have a malfunction, the system change the regime, enters in a transitional regime from a stationary one. To evaluate this regime, two simulation paths are introduced in the model using separated simulation entity to block the handling equipment from normal activity. Next slide, please. For the discrete simulation model that we use it to study this transition from stationary regime to transitional one, presented in previous slide, the transitional regime parameters are recorded for the case of multiple scenarios presented in the next table. We have 9 of them. The simulation run, and from this scenario we obtain data for different installation for handling equipment in the terminal. The simulation run setting suppose 5 replication, then a warm-up period before the start of recording the simulation parameter for 1 day. Next slide, please. The results obtained through simulation are presented in the table on the slide. Are recorded there the average value for different parameters that we studied. Next slide, please. So some results from the table from the last slide. The variation between the 3 scenarios associated with stationary regime, because we had 3 scenarios associated with the first regime, the stationary one, and the rest of the scenario associated with the transitional regime, show the difference between the results obtained in different the regime of the system. For example, in the case of parameter waiting time for a free stacker for unloading process, the value obtained for stationary regime is approximately 0.05 hour, in contrast with a value of 0.12 to 0.16 hours obtained for transitionary regime. So this parameter is decreasing considerable. Another comparison can be made also for parameter waiting time for a free quiet crane for loading process, with different by 30% between the maximum value obtained for a stationary regime, 1.23 hours, in comparison with maximum value obtained for a transitional regime, 1.6 hours. Also, the number of containers loaded and unloaded are a little smaller in case of transitional regime, but this is normal because we put a condition and we introducing a malfunction for handling equipment to create this kind of regime for the analysis. Next slide, please. So we have some conclusion from our work. The main objective of the research was to evaluate the importance of transitional regime in evaluating serving parameters for a transport terminal. This type of regimes with vulnerability and malfunction are normally excluded from analysis by experts because it's difficult to evaluate their impact over the system and their periodicity and how many parameters have a malfunction simultaneously and so on. In case of discrete modeling, this barrier can be removed using software tools, as we did, for simulating the activity inside the terminal. Next slide, please. The input data in simulation must be adapted for specific cases when the system changes his stationary regime to a transitional one. The results obtained are the closest results to reality and help to have a good calibration and validation process for the developed model. And from our future work, we will be focused in starting to develop a methodology for estimating the probability of transition between a transitional state to another, and how can be obtained the stationary regime from a transitional one. Thank you for your attention. This is all from my part.
Thank you very much for interesting presentation.
Thank you.
Do we have question to our presenter? we don't see any questions, so also maybe later, if you have questions, please send it to the presenter. So thank you very much once again for presentation.
Thank you so much.
Thank you very much. Now we are going to the last two presentations. The first one has a title, Assessment of Acoustic Microclimate and Rating of Noise Hazards in the Inner Transport System of a Bucket Wheel Excavator, a Case Study. Do we have presenter? We have presenter. Do you hear us? Hello? Unfortunately, we don't hear you, but we see you. You have turned down your, oh, now should be okay. Again, we don't hear you. Maybe you can change the microphone from the another option. If you can try. Please try to solve a problem because probably it is from your computer. Because I think that you hear me, yes? Yes, okay, thank you. But we don't hear you now. You have unmute your voice according to our indicator. It's still the same. Maybe you can select the microphone in the option. Please change this option. Maybe it helps. Same as system should be the best. Please try this option. Now you have unmute your voice again.
Ja proponuję, żeby prezentacja już poszła, a jeżeli uda się włączyć dźwięk naszemu prezenteru, to wtedy on włączy się do naszej dyskusji. Dziękuję.
Okay, thank you very much, Professor, for your advice. So we start this presentation, but I would like to ask the presenter to try again turn up your voice, okay? Thank you very much. Thank you very much for presentation. Unfortunately, we did not hear your voice, but I think that if someone have a question, we can send this question by email to our presenter. So now we are going to the last presentation today. The last presentation has a title, The Impact of Various Factors on Poultry Deaths During Local Transportation and Economic Implication. Do we have presenter?
Yes, do you hear me?
Yes, we hear you, we see you, we see your presentation, so please, time is yours.
Excellent. Dear Chairman, ladies and gentlemen, my name is Dr.Antów and I have prepared a paper entitled The Impact of Various Factors on Poultry Deaths During Local Transportation and Economical Implication. Next slide, please. Farming of poultry is an important economical aspect of European Union economics. For instance, in 2018, we produced over 30 million pounds of poultry, and in the United States it was over 50 million in 2017. So the scale is really big. Next slide, please. In 2019, the number of poultry produced worldwide expanded to 130 millions of tons. According to the analysis based on data acquired from 1st June 2018 and 31st May 2019, alone in the city of Rzeszów, according to the research material, which consisted of the data that was acquired from Rzeszowskie Zakłady Drobiarskie Resdrop boiler slaughter facility, the number of boilers transported to this facility amounted over 20 million 689,000 and 592 living organisms. The birds were transported from farms located within a radius of 50 kilometers, and the number of dead animals was determined during unloading of the birds at the slaughterhouse. Next slide, please. Nowadays, we use automated devices to provide optimal conditions of bird catching from their farming facilities. Next stage is loading of these birds on the transportation trucks, which then transport the birds from farming facilities to slaughterhouses. What is important, the modern devices, modern vehicles used for birds transportation have a lot of open spaces, so the birds won't suffocate during the transport. However, still we meet some economical losses during this procedure. Next slide, please. In European Union, there was a number of research conducted on the so-called DOA indicator. DOA indicator comes from death on arrival indicator and provides us with the information of how many birds didn't survive the transportation procedure. For instance, in Czech Republic, according to various researchers, the DOA indicator for broilers chicken varies between 0.237% and 0.925%. Whereas in Germany, this value is mediocre at 0.46%. However, in Poland, we don't actually have such a research conducted yet. For the whole country, this value is unknown. In this research, we provided some data on the Zakłady Drobiarskie RESDROP facility in Rzeszów. However, however, there is not enough information about other facilities in Poland. For the European Union as a whole, the DOA indicator for broilers is about at 0.35%. Next slide, please. The research objective of this experiment was determination of various factors responsible for losses during local transportation of poultry and their economic implications. Next slide, please. In this research, we determined the economical losses during transportation, and they were estimated based on the DOA indicator and previous publication by Tereszkiewicz et al. In 2019. In order to verify the combined effects of transportation, transport vehicles and the travel distance of poultry, there's two-factor analysis of variance Fisher-Sendekor F-test with the level of significance alpha equals 0.05 was adopted. Next slide, please. Here we can see the table with the relationship between the mortality rate and the distance and type of car, which is summary of the analysis of the variance. As observed, the factor significantly differentiating the mortality rate is distance with p lower than 0.05, and also important is the interaction of distance and vehicle type, where p is lower than 0.05. Next slide, please. The dependence of mortality rate of on the distance of the travel of the boiler chicken is presented on this table and figure. We can clearly see that there is obvious dependence of the transport distance and the mortality rate with direct increase of mortality rate with the increase of travel distance. Next slide, please. Another information was the dependence of the mortality rate on the distance and vehicle type. So two factors were analyzed. The significance of the distance and vehicle type interactions results from the fact that for transports up to 100 kilometers, the highest mortality rate was recorded in semi-trailers and the lowest in solo transport vehicles, while for transports of a distance of 101 up to 300 kilometers, the highest mortality rate was recorded in trailers and the lowest in transport by semi-trailers, while in the case of transport over distance of 301 up to 400 kilometers, the highest mortality rate was recorded in solo transport and the lowest in transport by semi-trailers. Solo transport over 400 kilometers has not been reported. The average mortality rate in this scenario was higher for transports in the semi-trailers and lower for transports in trailers. Next slide, please. Here you can see the dependence of the DOA indicator from the temperature during the transport. It was observed that at the temperature below 17 degrees Celsius, that on arrival indicator was the lowest, while above the 20 degrees Celsius, the indicator was the highest. And as observed the temperature with the growth of temperature, the DO indicator increased as well. Next slide, please. Also, we determined the dependence of the mortality rate on the distance and the temperature. So these two factors were analyzed. The significance of the distance and temperature interaction is mainly due to the fact that for transports of up to 200 kilometers, there was no influence of the temperature on the fatality rate, while for transports from 201 up to 300 kilometers, the highest mortality rate occurred at temperatures above 20 degrees Celsius, and the lowest at the temperature below 17 degrees Celsius. For transports over a distance of 301 up to 400 kilometers, the fatality rate was lower at the temperature below 17 degrees Celsius compared to transports at temperature above the 17 degrees Celsius. For transports over distance of 401 up to 500 kilometers, the fatality rate was definitely higher at the temperature above 20 degrees Celsius compared to transport at a temperature lower than 20 degrees Celsius. Next slide, please. To sum up, in our research, 20,263,7 birds were transported. Out of this number, 136,832 birds were dead upon our arrival. This allowed for calculation of the indicator, which was 0.68. The total value of dead birds amounted to 1,268,444 zloty. And on this table, we see the dependence of the economical losses on the transport type of on the vehicle transport type, and we can see that in general the implication of solo transport were neglected because the values of solo transportation were too small. And the mass of transported birds is not statistically interesting because it has no impact on the mortality rate. Next slide, please. Thank you for your attention. I'm glad I could participate in this conference, and I'm awaiting any questions. Thank you very much.
Thank you very much for interesting presentation. Do we have any question to our presenter? We don't see any questions, any people who would like to say the question. So it was last presentation during this session. So at the end, I would like to say thank you very much all presenters for interesting presentation, or participants. Thank you very much and see you in real conference. Thank you.
Dear Chairman, maybe I say thank you as organizer of this conference, and I wish all the best for all participants. And I think that you can participate in another sessions of your interests. Thank you for all.
Thank you very much.